Got a fairly simple nugget here for you on what is really a fairly simple Windows service. That Windows service is network load balancing. And to be perfectly honest, one of the most challenging parts about NLB is just recognizing when you should use it, particularly in contrast with when you might use Windows failover clustering. So let's spend a minute talking about first why NLB even exists and the types of things that NLB is really intended to do. Because this will become important as we start in the upcoming nuggets to talk about things like failover clustering. You will find throughout your career as a Windows administrator that you'll be implementing NLB primarily for a very small number of potential reasons. Most often, NLB is the tool that load balances IIS services or web services. If you got a web server, you need to take a couple of web servers and connect them together, load balance, high availability. NLB is your solution for doing that. NLB can also help in a couple of other cases as well, and these are kind of less used in many circumstances, but they're no less important. If you have a remote desktop services environment, multiple remote desktop services hosts servers, NLB is a way in which you can take those RDSH hosts and then load balance the users, the incoming user connections across RDSH hosts. You can also use NLB for VPN server farms, and most specifically things like TMG, like the Threat Management Gateway, which is one of those sort of slowly slipping away sorts of solutions that Microsoft has. But for the most part, the vast majority of times you're going to see NLB being used is when you're going to use it to support load balancing web services. And in this nugget, we're going to talk just exclusively about that use case because it is more than likely the fact that the only types of questions you're going to get asked have to do with implementing NLB for the purposes of load balancing IIS. What's important to be, the differences here are important between NLB and Windows Cluster. And that is because the number of services that are actually running, so the count of actual services, is different between NLB than is in Windows failover clustering. So let's assume here that I've got my happy little user here, right? And my happy little user is attempting to connect up through some network to my services. Now in a single server world, right here, so this is my IIS server, I can connect up that user so they can access the website. Simple, standard, turning on of IIS services and loading a website. But in the case where that IIS server should actually go down, well, then the web service is also down. So the user is no longer happy. He's in fact somewhere less than happy. Maybe he's nonplussed or maybe a little sad. So we incorporate technologies like NLB in order to provide high availability for web services. So let me come back here and get rid of my little down server marks. And also for load balancing. I mean, that's why we call it load balancing here. So with NLB, I have the ability to take multiple different IIS servers and then essentially craft them together, connect them together into what is alternatively called a farm or a cluster. The term cluster is almost a bit of a misnomer, but a collection of hosts that are able to respond to this happy little user whenever he makes a request down here through the network. The most important thing for you to recognize as far as what kinds of services NLB works best with is that NLB is really designed for services that are generally stateless. And that is because the activities going on here on one node are not generally understood by the things that are going on the other nodes. So if I have some sort of thing going on here, this server happens to be the one that's processing the request by my happy little user. Well, this server has no idea that this server is even really doing anything. The only way that a server might know that the other servers are actually doing something is because down at some level below your web servers, you might have a database or an application server. So an application server or a database server that these three machines connect up into. It is in this location where your stateful-based information generally gets stored. If you're familiar with an N-tier solution, an N-tier solution tends to have a web tier, an application tier, and a database tier. The only thing I've done here is I've consolidated the application tier and the database tier just simply because I'm running out of room at the bottom of this screen. So it is NLB that allows us to then provide load balancing services and failover services for that first layer, the web services layer. And it is other technologies that we will then use at the lower levels for the application and the database layer to handle those load balancing and failover needs there. That's where you end up typically implementing solutions like Windows failover clustering. Now, in this nugget, we're going to spend some time talking about the implementation of NLB across a 2-node cluster, a farm of 2 different nodes. We will install NLB on the first node, and then we will then, from the first node, add the second node as a node to the cluster. When we do that, we're going to talk a little bit about some of the NLB prerequisites. Now, there are a couple of different ways in which you can set up NLB's networking. And one of the best solutions still today involves the use of having 2 separate network cards per server, where each network card is on a different subnet. This is necessary in a lot of configurations because of the way that the network addressing is actually handled by NLB. Now, each server here, right, each web server is going to have its own IP address. And each web server here also has its own MAC address. But when we create an NLB cluster, what we are creating is essentially a virtual IP address, and in some cases with a virtual MAC address as well. It is because of the way that we create these virtual IPs and these virtual MAC addresses, depending on the selections we choose, we'll talk more about that in a second, that will determine whether or not it's necessary for us to have multiple network cards and multiple network subnets. In this environment, we'll talk about how to accomplish that across multiple subnets, just so you can see what it looks like. When we also configure these NLB clusters, we have to define how we want the cluster to behave whenever incoming requests start coming in from multiple different users. Now, we have a lot of different options in which we can do that. These options, one of which can be determined through what is called affinity. And affinity is just simply a configuration that we define across our NLB servers to say how sticky do you want this user's requests to be each time the user makes a request for a new web page. If you want that user to constantly be going on to a different web server, well, then you can just disable affinity entirely. But if you prefer that this user always end up going to this server for one reason or another, and that the second user over here always end up going through to another server, you can accomplish that as well. So that's just by setting up affinity, and there are a couple of different rules for doing that. I've told you also that NLB is designed primarily for IIS, but it's also designable, or you can implement it, for other solutions as well, like RDS, like TMG, and so on. And so while you're going to see a lot of stuff that has to do with IIS, you actually have to define which ports you're interested in load balancing. You're generally not going to find yourself load balancing every single TCP or UDP port on a server. That's generally not what's done. No, instead, what you're looking for in the IIS case is for load balancing, for example, TCP 80 or TCP 443, if I'm depending on if I'm using HTTP or HTTPS. So if you're using RDS, you're going to use 3389, which is the RDS port. The other solutions have different ports. You need to know which network port you plan on load balancing whenever you implement an NLB cluster. We'll also talk about how to configure the operations mode, which I'll talk more about in a minute, and a very quick note here on upgrading an NLB cluster that I will save for the very end. Now let's pop over here into our environment. I am here on a host nlb1.company.pri, and I want to show you that I have another host here called nlb2.company.pri as well. Now, in both of these cases, I told you about the fact that one of the requirements, depending on the configuration, is for you to have multiple physical network cards plugged into this server, and then those network cards to be on different subnets. This can be a production subnet as opposed to a management subnet, or it can be just two different subnets that you have for your production data center. This configuration with multiple subnets provides the most workable solution without some of the idiosyncrasies you can see with only having a single NIC. You'll see that I have here one NIC on the 1 net and one NIC on the 2 net. Now I know in nuggets previous to this one we had all those different networks that were associated with different geographic locations. Let's just ignore the fact that we've set those up for now because we want to focus just on a single site. And I didn't actually feel like creating multiple extra subnets to confuse you. On this server, NLB1, I have 1.205 and 2.205, and on the server NLB2, I have 1.206 and 2.206. On both servers also, I have gone through and added in the NLB feature. So you won't find NLB here in the list of roles. You'll find it on the second screen here for network load balancing here in the list of features. There's absolutely nothing else that you really get out of that installation. It doesn't even require a reboot to get NLB services up and running. So I wanted to get that installed on both servers because having it installed is the first step in the process. once it's installed, you'll find the Network Load Balancing Manager tool that appears here in your list of tools. This tool is kind of a curious one because as the years have gone on and the iterations to the Windows operating system look and feel, the NLB Manager tool is one of the ones that just almost hasn't changed at all from its earliest days. I mean, back in the NT4, Windows 2000, 2003 days, this tool looked pretty much like it does now. So it's kind of humorous how Microsoft has spent some time and effort to update some tools, but this one for some reason just doesn't seem to get any love. Let's talk about the first process, which is that of actually creating a new NLB cluster. Okay, so one of the things we have to do here to begin with is simply to just start by creating a new cluster. When we do that, the first thing we want to do is connect up to the first host that we want to be part of the cluster, which in our case will be NLB1. If I choose connect here, we'll see the two different interfaces that are available for configuring this cluster. Now I have two different options here, one of which I'm going to use for my traditional management traffic, so the kinds of traffic that needs to go directly to this host. The other connection, or the other network, is here for the kinds of traffic that is intended to be load balanced. Now let me kind of explain to you, let me grab my pen here, let me explain to you one of the reasons why this is important. So let's assume then that I have my two hosts here. Right? Here's NLB1 and here's NLB2. And I've got this sort of virtual IP address that I'm about to create up here that I'm going to put it on the 2net. Well, and actually I also have these two network connections here that are on the 1net each apiece. The whole point of NLB is so that when I've got my user up here and the user needs to connect up into this environment, they can then address the web server through some 192.168.2.0/24net, right? Or whatever your subnet happens to be. NLB will take any of that traffic that is directed to that address, whatever address we end up choosing here in a minute for this NLB address, this cluster address. It will take any of that traffic and then direct it to one or the other of these two servers. And so you're never really going to know which server that you end up getting onto. And that's the whole point behind NLB. NLB is designed so that if one of these servers goes down, well, then the other server has the awareness that it's gone down, and so the traffic continues to propagate into the correct location. It helps you during those situations when you do end up losing a server. But there are occasionally the times when you, the administrator, so here's you with your fancy administrator hat on. I didn't know admins had fancy hats, but let's assume you do. You as an administrator sometimes need to get directly onto a machine, right? You need to know that you need to patch NLB1. Well, the reason why we create these separate subnets is so that you, the administrator, can go to the 1net address and know that you're getting on this server without having to go through the balancer and worry about which server you're actually getting on. This becomes very important, as I said, for management tasks, when you got to patch the server, all the usual stuff that you're used to thinking of as far as your job with your fancy little administrator hat. And like I said, I want to know what those hats look like. Do they actually look like Abe Lincoln hats? So let's throw the interface to be used to configure this cluster as the 2net interface. I'll choose next here, and I have a couple of host parameters that I need to configure here on this next page. The first of these items is one that is perhaps the most misunderstood, or the most easily confused item in all of the NLB configuration. And that is this item here called priority, the unique host identifier. Obviously, we're going to have multiple different hosts that make up this NLB cluster. And in that configuration, we're going to define one or more different TCP and UDP ports that we're going to load balance. But because I'm defining that TCP or UDP port, the rest of the TCP or UDP ports are going to be left not load balanced. This priority value is what tells the cluster when an incoming request comes in on a port that is not defined by the cluster. So assume that we're going to cluster TCP 80 here. If I get a request on TCP 81, well, then those requests, those that aren't defined by a port rule, are going to be sent to the cluster host with the highest priority, or the lowest number. Okay, so let me say this again, right? So I got TCP 80, that's what I'm interested in. And then I have every single other TCP port in the world, all the way up to 65.536. Anything that comes in over any of those other ports needs to go somewhere. And so we define what that will be by this host priority here. Now this is defined as a priority because, again, in a cluster that has multiple different nodes, I need to support the loss of a node. So that if my priority 1 node goes down, well, I still have the ability to route this weird, different traffic, this unexpected traffic, to one of the hosts. I'm going to dedicate one of the IP addresses for this, which will be the 2.205 address. That's the one that I set up by just plugging it in my network settings. I can set what the initial host state will be, which will be started or stopped or suspended, whichever one I'm looking for. And then do I want to actually leave the cluster not operational, or this host not operational after the computer restarts? In certain circumstances, you may want to set this so that you have the ability to complete some configurations, for example. Maybe you're setting up the NLB cluster, but you're not quite ready to turn it on just yet. In this case, all the defaults here are perfectly fine for me because I have a host that I want to load balance. I'm ready to go, and I'm going to leave it in the started state here. On the next screen, I have to identify what the IP address, the virtual IP address of the cluster is going to be. So back to my little drawing here, back to my 2 little hosts. Here are my 2 NLB hosts. There's NLB1 and NLB2. I am now at this point creating whatever this address is going to be here. That will be the location users will go to begin load balancing. So if I know that my web page, so the www.company.pri needs to go to 192.168.2.220. That's what my DNS record will be for that website. Well, it is in this location right here where I'm going to punch in 2.220. This is important to recognize because, as you can see here, I don't have to add just a single cluster IP address. I can actually add in multiple different cluster IP addresses if I want. So a little bit later, when we get into configuring the port rules, I have the ability to identify different cluster IP addresses that may or may not correspond to different port rules. So I can get a little silly here with how I end up dealing with the load balancing that I need. Let me plug in that address, 192.168.2.220. It's just one I kind of picked out of the ether, and choose OK. Then I'll choose Next. This creates the IP address for the cluster itself. Now, in addition to that, I also want to create an FQDN for the cluster as well. This will be NLB farm.company.pri. So this is just going to be an address that I will use that corresponds to my 2.220 address. We'll have the option of creating other ones a little bit later on. This takes us now down to the other of the more complicated configurations here with an NLB cluster, and that is what is called the operation mode. Now, I told you that some of the reasons we end up setting up multiple adapters here has to do with just so that I can make a management connection in. Others have to do with how the MAC addresses of these clusters end up getting either obfuscated or directly used whenever I set up the cluster itself. The first of these, the unicast operation mode, these days is generally the default, and it allows the cluster's MAC address to completely replace the MAC address on the individual host adapters on each host. So, again, back to my little description here and my little virtual address here. We're not talking about IPs right now. We're just talking about MAC addresses. The MAC address here, so A5:B4:C3:, and so on and so on. This MAC address will be the one that replaces the individual MAC addresses down here on the individual hosts when I set unicast as the cluster operation mode. This is probably the best solution when it is supported by your network adapter, and if you're putting this in a virtual machine, when it is supported by your virtual environment. There are some virtual environments that have MAC address spoofing turned off, and when that's the case, you cannot use the unicast cluster operation mode. And that's kind of an advanced topic, but if you happen to be using VMM or vSphere, disabling MAC address spoofing is something that will prevent this cluster operation mode from happening. Unicast is in many ways probably the best of the three, at least in terms of the amount of traffic that it can generate on the subnet. The multicast operation mode uses a slightly different configuration in that each of these individual MAC addresses on the computers still remain the same. They're not obfuscated by the cluster's MAC address. And so the cluster ends up communicating with the individual nodes down here using multicast. Now, one of the problems with multicast, as we talked about a little earlier, is multicast is one of those protocols that the network teams love to hate, because multicast has a tendency to flood the network switches. You're essentially sending packets out across that subnet. And so your network teams tend to not like multicast too much just because it can have a tendency to perhaps slow down the traffic in that environment. It definitely is a little bit chatty for the different machines that are talking in that environment. This can be mitigated somewhat if your routers and switches support what is called IGMP multicast. Now, IGMP multicast limits the amount of switch flooding that can occur by limiting the traffic to just the ports that NLB actually cares about. The problem with this is that some network equipment doesn't actually support IGMP multicast, and other network equipment, most other network equipment, requires additional configuration for IGMP multicast to even be turned on. So if you don't have a great relationship with your network team, you may not actually be able to get to them through to them the information that they need in order to turn on IGMP multicast, because there's some effort, there's some things that they actually have to do in order to make it work. Again, unicast is the best solution for most situations, except if your network cards don't support it, the MAC address virtualization piece here, or if you're not allowed to do MAC address spoofing because of a virtual environment rule or perhaps a security rule that's set into place. I'll set unicast here because it's just the easiest of these three to implement, because I control the network and I control the servers. It is in this next screen where we can then define which of the TCP and UDP ports that we want to manage or load balance here through our NLB cluster. By default, across all the cluster IP addresses, I'm actually now load balancing every single port, every single TCP port, every single UDP port. This is not a great configuration. It's really not something that you want to do. So what we want to do is then back this down just to the ports, the ports or port ranges that we're interested in load balancing. Now in our case, this can be port 80, so 80 to 80, or 80 or 443 to 443. I mentioned earlier that you can actually use this cluster to create multiple different cluster IP addresses and associate them with different port ranges. Whew, man, as a side note, my allergies have been going nuts this season, and so if I sound more like a frog than I normally do here in this series, I gotta tell you, the allergies are just killing me right now. Anyway, so please forgive the Kermit the Frog hi-ho portions of this nugget and all the rest of them here in this series for some reason. Where were we? We were talking about cluster IP addresses. Correct. So one of the neat parts about an NLB cluster is your ability to actually create multiple different cluster IP addresses that correspond to different websites or different TCP ports specifically. So you may or may not be aware in IIS, so again, here's my two IIS servers. In IIS, I have the ability to create different websites. And when I do, I can associate those websites with different ports. So the default port for IIS is port 80. But sometimes you see other ports here like port 8080, so 8080, or port 8081 sometimes. Obviously 443 is an option. And within IIS, I can do some pretty fancy footwork to identify a port with a specific website. So anytime I come into port 8080, it's a completely different website than it is if I come in over port 80. It is here within the port rules where I can then take it one step further and define different cluster IP addresses to be associated with different port ranges. So if you're coming in over 2.220 and IIS is aware that you're coming in over 2.220, well then go ahead and load balance that port 80 traffic. That's what I'm interested in. Send it to all the different servers because they're all configured similarly. I need to identify the protocol, TCP/80 being the protocol most used for web. And then down here is where I have one other option for determining how I want to filter the clients that are coming in. Or actually, not there, right here. This filtering mode is probably the best option for a test question that you're going to see on this exam, because Microsoft has been testing on this filtering mode stuff since, I think, the beginning. The filtering mode is the mechanism, the configuration that determines how different users get mapped to different servers in the environment. Okay, so again, to draw. You're probably tired of seeing all these blocks. So let me create now 3 different servers. And I got my virtual IP up here, my cluster node IP. That cluster is dividing things out. Here's the network. And up here is happy little user number 1 with an extra leg, apparently. Here is happy little user 2, now down here. In the default configuration, you'll notice that the filtering mode here is set to single. This use of the single filtering mode does more or less a hash on the incoming IP address of the user that's connecting from the outside world. So maybe this guy's out at a hotel somewhere and he's coming in through 122.2.4.6. And this person is in a, I don't know, in an airport somewhere. So they're on 24.1.2.3. The single filtering mode will create a hash based off of the IP address coming in and use that hash to send that user to the same machine every time. Every time that user comes in, they're going to get directed to the same machine in the cluster up until the point that that machine happens to blow up. And then the hash gets reconfigured to point the user to a new machine. It's very important configuration here because it is by setting the filtering mode to single that gives you a little bit of capacity for statefulness on these IIS servers. This ensures that every time you come into the same server, if you set this instead to none, well then there is no hash and the user will go randomly to any machine in the environment. There's no way to tell which machine that user is going to end up going to. The third of these is the network hash. Now the network hash is kind of a curious one because the network hash will actually identify user or actually route users based on generally the first 3 octets of their address. So did you hear that? My voice is cracking like a frog again. Oof, allergies are crazy. The first 3 octets here are going to be 122.2.4 and 24.1.2. Now the neat part about network is that if you have, for example, a couple of different sites, so here we have our 3-site configuration with Denver and Phoenix and Las Vegas. A lot of times the network configurations between these are that in the Phoenix, the Las Vegas case, I might have the 2.0 site, the 192.168.2.0 site, and the 192.168.3.0 site. If I set this to network, this will ensure that everyone in the 3.0 site are going to end up on one of the servers, and everybody in the 2.0 site will end up on the other of the 2 servers, all the time and always until one of the machines dies. You have to be careful with this though, because in a lot of cases people end up implementing the network filtering mode and then having users that are coming in from the outside, so out over the internet somewhere. When those users are coming in out over the internet somewhere, more often than not, they're coming in through some sort of external proxy. And a lot of times those external proxies are going to be load balanced themselves. The problem is these external proxies, maybe it's at 10.1.2.3 and 10.1.2.4. The problem with these external proxies is that this is the same network as that. And so the network filtering mode can sometimes have some unexpected results based on if the IP address of the incoming users ends up getting changed as it bounces through some perimeter proxy. All this is probably maybe just a touch more information than you need to know for the exam. I would be aware that there are multiple different filtering modes. I can set it to none and it just load balances and it doesn't care. I would know that single does it by IP address and network does it by network address. That's probably what you need to know for the exam. But this gives you, again, a little bit more of the reasons why these exist. If load balancing is not your cup of tea, if you're really just looking for failover, whether you can set this down here to single host if you want. Single host is going to direct everything to a single host and then direct it to the next host whenever that host just simply dies. Or I can disable the port range. I'm going to set this to the default here, which is multiple host and single, because that's what I'm looking for this configuration. I'll click OK, and you'll see here that I now have the defined port rules. I could create more if I wanted to, and then choose Finish. Now that I've completed this, though, I want to go back into the configuration to show you how this view changes just a little bit. Let me come here to my first host, which will be NLB1. And there we go. Now we're up. And I want to view the properties on this host there. And take a look now at the cluster, let's see, the port rules view here. You notice something's a little bit different between this view and the view we saw just a second ago. In the view we saw just a second ago, we did not have these characteristics here for load weight or handling priority. You have to actually go back into the properties of the individual host to get these things configured. And right now it's disabled because we we've got the load balancing services turned on. You can imagine a situation where I might have bought a couple of different servers, one that is a tiny little server and one that is a big, beefy, powerful server. So this one has, this one has 5 times, let's make this easy on ourselves. This one has 4 times the amount of processing power that one does. Well, in that case, it may be useful for us to change the load weight here so that the weighting of this server is unbalanced with the weighting of the other server. So if my load weight is, I don't know, if it's, maybe I should have made it 5 times. If it's 50 over here, then it's going to be 10 over here. I want to divide these things out so that they're essentially, well, it wouldn't be 50 and 10, it'd be more like 90 and 10, I think. So 90 and 10 to divide those two out between the two servers. Setting the balance of these allows me to use dissimilar servers in this load balancing configuration. So I send more users to one server and fewer users to another. The other piece down here, the handling priority, is something that only is taken into account whenever I've set the single host filtering mode. I told you single host always sends every request to the same server over and over and over again until that server dies. Well, it is the handling priority that helps me determine or tells the cluster which of these servers to send it to. Priority 1 goes first, then priority 2, and so on and so on. So don't ignore these port rules after you've gone about configuring the cluster because, well, there are a couple of additional configurations that get set once this first host gets brought into and the cluster starts operating. As with everything in Windows these days, there are also some PowerShell commands that I can use. If I come here, for example, to Windows PowerShell and run it as an administrator, there are a couple of interesting commands I'd be aware of. Get NLB cluster node. Cluster node right here. We'll get information about the cluster node. So NLB1, there's the content. And if I FL start here, you can just see there's more kind of extended information. I'm not filtering on ICMP. There's my GUID on the adapter. Do I persist that suspend on the reboot? No. What's the state? The cluster is indeed converged, which means that it's a happy cluster now. All the nodes are aware of each other. I could use get NLB node, cluster node. I can set that to, for example, set NLB cluster node, or not set, add NLB cluster node. So, for example, if I want to add a new cluster node, I can accomplish that. Add NLB cluster node, new node name NLB2, and then new node interface Ethernet. I think it's Ethernet 1. That would add in that additional cluster node if I wanted to. I would, just with all of these, be aware of what the commands are that are associated with NLB, GCM, where name, like, NLB. There's the list of them. And again, just with all of these, not necessarily deeply about how these commands work, but the mapping between the commandlets and the things that I'm showing you here in the graphical user interface. So again, understand that mapping just like with all the different technologies that we're talking about here. When it comes time to add in more than just that one host, we actually have to add in an additional NLB host to get this thing up and operational as really a load balancing cluster. And I can accomplish that here by adding the host to the cluster. The process to accomplish this is really easy. nlb2.company.pri. Choose to connect. Once it connects over to nlb2.company.pri, I'll see the 2 different IP addresses that I can use. I'll use this 2net address here, set its priority, set the dedicated IP address, choose next, set the port rules that I'm interested in this host participating with, choose finish, and after a second or so, I should see that NLB2 then joins the cluster reconverges again onto both of these hosts, and then lets me see that I am successfully load balancing hosts between the two, or requests between these two hosts. After a second or so, yep, there we go. We have a happy little cluster here at this point. Very cool, very cool. Once the cluster is converged, and I got all the nice little green lights here, the cluster is now successfully load balancing the traffic that I've configured. But sometimes I may need to go about either upgrading the cluster or patching the cluster, or any of the activities that are necessary, the daily care and feeding activities of a Windows world. There are here built into the NLB console the ability to accomplish some of these cluster activities here under control hosts. I can start or stop the NLB service. This drain stop right here is one of the commands that I think you probably want to be aware of because you only ever see this here in NLB. And all drain stop is instructing the cluster to continue to operate until the existing connections that it's working with have been drained out. That the node will refuse any new connections. Any new client connections are going to go somewhere else, and it will complete what it's doing. Once you've done that, once you've turned it to drain stop, once all the connections are no longer there, well, then you can go about patching that server or rebooting it or even performing an upgrade. Which takes us to our last little point here, which is upgrading an NLB cluster. And there's a variety of different things that you probably got to know. You got to make sure that the cluster configuration is the same. You're going to have to go through the Windows upgrade process and make sure that the upgrade, you can actually upgrade that host. But the most important thing for this example is to recognize that it is possible to do a rolling upgrade on an NLB cluster. You can just simply take your multiple cluster nodes here, power this one down, use the drain stop command, and then complete the upgrade on this host, bring it back into operations, and then complete the second process on the other host. That rolling upgrade process makes upgrading a cluster a remarkably easy thing to do. So what have we talked about this nugget? We've talked about network load balancing and what is really a fairly simple solution. We went through the installation of NLB and configured some of its prerequisites, talked about the very important tasks of affinity and setting port rules, made some very important determinations here about the type of cluster operation mode that we want to use, depending on whether our network team wants to use multicast or whether we can actually use unicast, unicast being probably the best of the available solutions, and then spend a quick moment in here talking about upgrading that NLB cluster. Coming up next, we're going to shift gears and talk about Windows failover clustering, which, although it and NLB share the same word, that is the word cluster, is a completely different solution for providing high availability for completely different services. We're going to be working with a lot of different services here in these couple of nuggets coming up, but actually getting your failover cluster built, arguably the hardest part of the process, is the topic for our next nugget. So until then, I hope this has been informative for you, and I'd like to thank you for viewing.